Okay, welcome everybody to this session, tutorial session on introducing Annif and automated subject indexing. I wanted to point out that attendees, you have an icon labeled chat. If you think of any questions as you're listening to the presentations, please go to that chat channel and indicate maybe who you're asking the question to. We will have, after each presentation, we will have 5 minutes for short questions to clarify things that have been explained in the presentation, and at the end we will have a Q&A session for more general questions. So I'd like to start by introducing the first speaker, Osmo Suominen of National Library of Finland. He helped build the Finnish ontology service and has been leading the development of the Cosmos vocabulary browser and Annif, which he will now present. Osmo?
Thank you, Tom. I will try to share my presentation. So yes, I will be giving an introduction to Annif and automated subject indexing, but first I will present myself briefly. So my name is Osmo Suominen and I'm working as an information system specialist at the National Library of Finland. Before I joined the National Library, I completed my doctoral thesis on semantic portals, which involved applying semantic web technologies to various web-based applications where controlled vocabularies were in an important role. And I joined the National Library 7 years ago, and my first assignment was to together with others to set up the Finto thesaurus and ontology service that we use for publishing controlled vocabularies such as thesauri, ontologies, and classifications. And I've also been working on opening up our bibliographic metadata as linked data, and then, of course, today's topic, automated subject indexing. And while working on these projects, we have produced several open source tools that we've shared for others to use, including Scosify, which is a validation tool for Scos vocabularies, and Cosmos, which is the technical platform for Finto, and then Annif, the automated subject indexing tool. So, and this is the Finto service. It's a place where we publish vocabularies, and our most important subject vocabulary is the general Finnish ontology YSO. It's trilingual in Finnish, Swedish, and English, and has more than 30,000 concepts. And we use it in many Finnish libraries and other institutions as well. Okay, but then let's talk about subject indexing. This is also known as topic indexing, topic assignment, or term assignment, but depending on the context. And it's similar to the practice of tagging, which is used on many web platforms. And in a machine learning context, multi-label classification is very close to subject indexing as well. And the problem that this tries to solve is that in libraries, we generally have very large collections of different kinds of documents, and to make them findable, we attach subjects to them so that they can be searched using those subjects. And but this is a lot of work. It's manual work usually, and it would help to have a tool that could assist us doing this. And for example, suggest appropriate subjects for a document. And this is not a new idea. This has been, systems like this have been developed at least starting from the 1960s, for example, with the medical subject headings used for medical literature. And there are many tools and products that can do this. But from our perspective as a national library of a small country, they suffer from a few problems. First of all, they usually don't support the national languages we use, Finnish and Swedish. And then the other problem is that they don't support the vocabularies we use. So for example, many of these tools are tied to a single vocabulary. Even if it's an important one like mesh, it's not the one we are using. And the third problem is that they tend to be proprietary products that cost a lot of money. And then if you buy it, you get a black box. You can't affect how it works. And then you're stuck with the vendor. So this is not a very attractive, it's not a very attractive idea to buy a product like this. So instead, we started thinking about whether it would be possible to leverage our existing metadata and to build a tool that could sort of detect patterns in the data we have and then help us produce more metadata. And the most important source for metadata we have in Finland is the Finna Discovery Service. It's like a search engine for museum, library, and archive collections. And currently it has about 15 million objects, and not all of them have a subject metadata, but many do. So you can get like maybe 10 million some kind of documents or objects with subject metadata. And we use this to train machine learning models that can then assist us in producing more metadata. And so let's talk briefly about those algorithms. There are two main approaches that are useful here. The first one is a lexical approach, and this is also the more traditional one that has been used for many decades. And the basic idea here is that we have a controlled vocabulary with terms, and then we try to match those terms into terms or words that occur in documents. So if we have a sentence like this, that renewable resources are a part of Earth's natural environment, and then we have a subject heading or a term in a vocabulary called renewable natural resources, an algorithm could match this to the sentence and notice that there is a potential match here. And then when it goes through the entire document, it will produce a lot of these candidate matches. And then the challenge is to filter those and find the ones that are really describe the important topics of the document. But anyway, this is the lexical approach. And one benefit of this approach is that you usually don't need a lot of training data to build an algorithm like this, because it mostly relies only on the vocabulary and not on examples of how it has been used. The other approach is an associative approach, and this is more in line with machine learning, but in general, any kind of statistical methods are involved here. So here the idea is to learn correlations between concepts that are used as subjects and terms or words that occur in documents. And so for example, this same concept, renewable natural resources, the algorithm could identify based on many examples of documents with this subject that this is correlated with the words that you can see in this word cloud, like renewable or energy or resources or environment or technology. But this kind of approach requires a lot more training data to get good coverage of each subject. So often you need hundreds of thousands or maybe millions of examples to train one. Okay, and here are some of the algorithms used in Annif. There's one lexical algorithm. It's called MAUI, and it's a well-established tool developed some years ago at the University of Waikato. It's a good baseline for lexical the lexical approach. And then we have several associative algorithms. The TF-IDF of similarity is very simple. It's a baseline method, but it's a good starting point. And then there are others like FastText and Omikuji, which are more advanced and also heavier to train. And these are implemented in Annif as they're called backends. So Annif is more of a framework where different algorithms can be plugged in. And in Annif, these algorithms can be used either alone, just a single algorithm at a time, or in a combination, which is called an ensemble. So to make an analogy with musicians, of course, the algorithm can be either a solo player or more like a quartet, like here, or quintet. And usually, or almost always, an ensemble is better than its parts. So when you combine algorithms, they usually cover for each other's deficiencies, and the combination is stronger than any of the individual ones. Here is a picture of the technical architecture of Annif. Annif is the big box in the middle. So it's a Python application built on the Flask and connection toolkits, and it has some modules to deal with the configuration and vocabularies and so on. And then there are these backends. There are regular backends that are just a single algorithm, and then there are these fusion or ensemble backends that combine input from several of these regular backends. And it has an API that can be used to integrate it with other systems. Okay, and so Annif is a tool. It's not specific to a single vocabulary or a specific language. It's multilingual, and if you want to use it, you need to access it through one of the available channels. There's a command line interface, which is used for the most administrative tasks. So, for example, to set up projects and then train those projects or models, and then for testing and evaluation on large collections of documents. Then there is also a small web user interface for interactive testing, and as I mentioned before, a REST API for integrating with other systems, because Annif is really meant to be like a microservice that is used by other systems, and not so much a tool of its own right, but something that you connect with other systems. Here is an example of how the API works. The core method of the API is called suggest, and the idea is that you give it a text. Here is just an example sentence, and then the API responds with suggestions of concepts that could be relevant for this input text. So in this case, for example, red fox and dog. And then each suggestion comes with a URI identifying the concept and the label of the concept, and then a score that is an estimate of how good the suggestion is, how well it describes the input. It's an open source tool, and it's being developed on GitHub, and so all the code is there, and there are issues and pull requests and so on, which are sort of the day-to-day development is happening there. And it's a Python code base, requires Python 3.6, and uses the Apache license, which means that it can be used for pretty much everything. And it has a good coverage of unit tests, and so. And there's also a lot of technical and usage documentation in the GitHub wiki. It is also available to other channels. It's a package that is published on the PyPI, which is the Python package index, and also we provide pre-built Docker images through the Quay.io service, which makes it easy to try out Annif in a pre-built container. And of course, the reason I'm giving this talk today is that I would like others to also apply Annif for their own data and their own problems. and the basic process is very simple. So you have to choose an appropriate subject vocabulary. For example, any SCOS vocabulary should work, and then prepare a corpus from existing data that you have, for example, in metadata repositories. Then load the vocabulary and train a model. I will show this briefly shortly, and then it can be used to suggest the subjects for new documents. So now I will do a brief demonstration of Annif, and just to show how to work with it. And in this demonstration, I will first load a particular vocabulary. In this case, I will use the SDW Thesaurus for Economics, which is a bilingual German-English vocabulary, a bit less than 10,000 concepts, and then train a small model using metadata from the EconVis portal, which is a collection of economics literature. And then finally, I will show how to test the model. So here you should see a window, and there within this is a virtual machine, and I'm showing showing the configuration for this Annif installation. And here I have already configured a small a project for this purpose, and just set some settings. And now I will need to load the vocabulary, the SDW Thesaurus, from a SCOS file into this project. It takes about maybe 20-30 seconds or so. I guess this is the classic demo effect. It takes longer than you expect. Okay, so now I've loaded the vocabulary, and now I will train the model from a sample of data from the EconVis portal. This is about 100,000 documents. So I'm training the model, and this is a very basic TF-IDF model. So this is the simplest possible model that you can use in Annif. It should take about 30 seconds to train this. Still training. So these the documents I'm training on are just titles, document titles from the EconVis portal. So there's not that much information per document. Okay, almost done. Now it's done. Okay, so now I can start up the web interface. And I will open a browser window. Okay, so this is the Annif web interface. And I will first test with something, just let's say economics literature. Enter some text here. And it will suggest subjects like economic theory, economics, bibliometrics. Okay, so that seemed to work. Then I will go to the BBC News site, and it seems that the big news item for today is about this banking scam involving the HSBC Bank. So I will use this article as an example on copying the text from the first part of this article and then pasting it here. So this is the let's clear the share buttons. Okay, do some cleanup here. So this is the article from the first part of the BBC news item. And now the suggestions for this small project that we just trained was banking history, banking law, bank regulation, and so on. These are it's basically recognizing that this is about banks, but it's not a very specific result. But then I have here also another project that I trained before this presentation, and this is an Omikuji model, a much stronger machine learning model, and I trained it on 1 million documents from EconBiz instead of 100,000, and it should produce better results than this. But it took about 40 minutes to train, so that's why I couldn't do it live here. And this algorithm suggests for the same text, United States, bank lending, banking supervision, money laundering, United Kingdom. So this is already a much better result than the previous one. It knows, for example, that this is about supervision and money laundering, and economic crime comes up as well. So here you can see that training a model from existing metadata, you can get suggestions like this. Okay, let's put that in the background. And if you want to try this out yourself, there is a very similar form on the Annif website at annif.org, where you can find some pre-trained models, especially using the Finnish journal Ontology. So you can test this on your own documents as well using that demo. So now I'm finished with the first part of what I'm speaking, and I can take a few questions. I haven't watched the chat window, so I don't know if there's anything that has come up, but after those questions, then there will be other presenters in the middle. Koralka Golub will talk about evaluation, and Annemiek Romain and Sarah Veldhoorn will talk about the case study, and then I will continue with some other aspects of Annif, how it's used and how we've evaluated it. Okay, stop my sharing now. So any questions at this point? I haven't seen anything in the chat window, so.
I just asked one question for clarification. The TF-IDF created a vectorizer. Is it easy to describe in plain English what a vectorizer is?
Yes, I'll try. In machine learning applications involving natural language processing, the input is of course usually some kind of text. And but to make a machine learning model on text, it usually you need to turn that text into some kind of numbers. And a vectorizer is basically a method for turning text into numbers. And the basic idea is that you just give every word that you encounter a number. So number 1 could be car, and number 2 could be dog. And then you just convert those words, the incoming words into numbers, because the numbers are then easier to process using an algorithm.
Okay, I don't see any other questions right now. So at your discretion, I think maybe we could move on to the next talk, and then we'll have more time at the end for questions and answers.
Yes.
So I want to introduce the next speaker, Cora Golub of Linnaeus University, who is going to talk about evaluating automated subject indexing.
Okay, thank you, Tom. Do you see the screen? Do you see the shared screen?
Yes.
Yeah, okay, thank you. Okay, well, thank you, Asma, for this wonderful presentation. We are often faced in automatic subject indexing with evaluation. It's quite complex. And then some state that it's possible to entirely replace manual indexing. Either results range from 50 or 60% accuracy, 90% accuracy, depending on context. However, how do we really know how good automated solutions are when we have so much context related to that? So I'll talk briefly about evaluation problematics. In 2003, Lancaster, in his known textbook, wrote that research comparing automatic versus manual indexing is seriously flawed because laboratory conditions are the ones that are applied out of context. And there are very few reports of indexing tools, automatic algorithms in actual operating information systems. And these challenges of evaluation are quite much related to two concepts, the concept of relevance and the concept of indexing. So I'll talk a little bit about each of them first. The challenge of relevance. Why do we want to talk about that when we talk about subject indexing? Well, the ultimate purpose of subject indexing is often making relevant documents retrievable. But relevance, how do we measure this? Relevance is a complex phenomenon. There are many possible relationships between the search query that the user writes and the documents that are retrieved. This is because relevance is subjective. It's also known to be multidimensional and dynamic, with a lot of research explaining this and giving examples. Let's just give one example. The relevance criteria may be very different even within psychology when they work on the same problem, let's say schizophrenia, if they come from different approaches to address it. So behaviorism, cognitivism, neuroscience, and psychoanalysis, a document may be about schizophrenia, but may be irrelevant based on which paradigm one is coming from. In practice, evaluation of information retrieval systems is based on pre-existing relevance assessments. This is known as the Cranfield model, where we have a gold standard. A gold standard comprises a test collection, which is a set of documents, a set of topics to which these documents belong, and a set of relevance assessments that say whether one document is about one topic or not. And then this has been heavily criticized, but it's still the common model. And in 2008, Sarachevich wrote that in spite of the dynamic and multidimensional nature of relevance, in practice, we still do only comparison against the gold standard. And he refers then to an early study on retrieval conducted in 1956, which powerfully influenced this. Here, Gall, the owner of this study, reported that two groups of judges could not agree on relevance judgments. And since then, it has become common practice to not use more than a single judge or a single object for establishing gold standard, which of course doesn't really work in context or in real life. This was a little bit about the first challenge when we do evaluation. The second challenge is related to subject indexing as such. If we look at the current ISO standard, which promotes on how to conduct subject indexing, it is really a document-oriented definition. We have 3 steps. We first determine the subject content of a document. We then conduct conceptual analysis to decide which aspects should we represent, and then we translate those concepts into a controlled vocabulary at hand. However, some collections are also indexed using request-oriented or user-oriented indexing, where the indexer's task is a bit broader, not just referring to a document, but trying to actually anticipate what topics or uses this document could be relevant. Another related problem with this is the fact that aboutness, like relevance, is also very context dependent. It depends on factors like interest, task, purpose, knowledge, even norms, opinions, and attitudes, like we also saw on the example of schizophrenia. Then each collection has its own indexing policy, meaning how many topics should be assigned per document and how deeply they should go when we describe topics. So if we look at school libraries, they will be very superficial and broad. But if we look at academic libraries or indexing and abstracting services for journal articles, they will be very exhaustive and deep. which means that a subject correctly assigned in a high exhaustivity system may be wrong in a low exhaustivity system. And something else. We have inter-indexer consistency, so consistency between two indexers, but also within one indexer who may assign different terms at another point in time. And this is really much related to higher exhaustivity and specificity and bigger vocabularies. Consistency will be higher if we have vocabulary of 100 terms, and it will be much lower if we have vocabulary of 14,000 terms. Also, indexing can be consistently wrong as well as consistently good. So high indexing consistency is not always a sign of good indexing quality. What does this all mean? It means that terms assigned automatically but not manually might be wrong, but they may be just missed by manual indexing on purpose because of an indexing policy or by accident. And this is why it is not good to use existing classes as the gold standard only. Because of these challenges, as part of a project, a number of colleagues where I was involved proposed a framework for evaluation. This framework wants to provide a comprehensive overview and therefore triangulates methods and explores multiple perspectives and contexts. It, depending on the resources available, advocates to apply three complementary approaches. The first approach is to evaluate indexing quality directly through assessment by an evaluator or by comparison with the gold standard, which we talked about just recently. However, in this case, the gold standard is carefully crafted, that we'll talk about in a moment. The second complementary approach is then to evaluate indexing quality directly in the context of an indexing workflow. So while catalogers assign index terms. And third one, because the purpose of indexing is improved retrieval, we want to see the effects it has on retrieval performance. In more detail, the first approach, evaluating directly through an evaluator or gold standard, here we can have two main approaches. One is to ask evaluators to assess index terms assigned or to compare to a gold standard that we mentioned before is the most common approach already. But what are our recommendations here in more detail? Let's say that we have a collection that has a number of different subjects. Within that collection, we can select three distinct subject areas that are well covered by the document collection. And for each subject area, we can select 20 documents at random. Then we use a team of at least 6 people, 2 professional subject indexers, 2 subject experts who are also end users, and 2 end users who are not subject experts, and have each of them assign index terms. Then we use our algorithm or several algorithms like ensembles in Annif or individual approaches that Annif, for example, provides. And we assign all the automatically provided suggestions. After that, we prepare one long integrated listing of all index terms assigned by any method. So by all algorithms, by the team of 6 people who assign them separately from each other, independently from each other. And then we have a long list of all the potential terms we could think of in this larger context. And then we have 2 senior professional subject indexers who are probably more experienced and preferably 2 end users, go through each of the index terms and then remove terms assigned completely wrong and also add terms missed by all the previous processes. As such, we will have a gold standard that is informed by much more evidence than just catalog records that we discussed before have some issues. Having said all that, the exact number of indexers, number of documents must be considered in the context and also take into consideration, of course, available resources. There are no studies known that I'm aware of how these numbers affect results, but intuitively, we can claim that less than 20 documents per subject area would make the results susceptible to random variation. And why do we choose different subject areas? Because it is known that certain topics are easier to automatically derive. For example, physics papers produce much better accuracy than do humanities papers, because humanities is on purpose often metaphorical and requires the reader to read between the lines and so forth. Anyway, this was the first step. The second step would be to evaluate machine-aided indexing tools like Annif in an indexing workflow. We are aware of medical text indexer that has been well researched and used in the US National Library of Medicine, for example. The purpose of this evaluation is to assess the value of providing human indexers with automatic index term suggestions. And here we recommend 4 phases. First is to collect baseline data based on unassisted manual indexing, as one usually goes about it. Then is a familiarization tutorial with the tool for the indexers to understand how it works. The main step is then an extended in-use study where we do 4 things. We observe practicing subject indexers, again in different subject areas, because the practices will vary. Then the indexers assess the quality of the automatic term suggestions. We also identify any usability issues. And finally, we evaluate the impact of term suggestions on terms selected. So how many of the suggested terms were actually selected and also why. The 4th phase is to also conduct a semi-structured interview that would provide further context on these choices and observations from phase 3. So such evaluation basically considers the quality of the tool suggestions, the usability of the tool, but also it's good to take into consideration the indexer's understanding of their task, experience with machine-aided indexing, the resulting quality of the indexing, time saved as some of the facets that we try to take into consideration here. And the 3rd and final step is to evaluate indirectly through retrieval performance, because the major purpose of subject indexing is successful information retrieval. So what we do here, we compare retrieval results from the same collection using indexing from different sources, meaning manual source, meaning different algorithms that we were testing, or the different ensemble or combinations of algorithms. And here the emphasis is on detailed analysis of how indexing contributes to retrieval successes and failures. So a recommendation could be to have a test collection of some 10,000 documents, ideally an operational collection with available control terms covering 3 or more subject areas so that we can compare again across subject areas. Then we index selected, or ideally all of these documents with all of the indexing methods to be tested. So say different algorithms or different implementations of the same algorithm. And then for each of the subject areas, we choose a number of users who are ideally equal number of end users, subject experts as end users, as well as information professionals. Then what happens is that users conduct searches on several topics. And here we could have different topics, free or controlled. One topic could be an extensive search, which is likely to benefit from the index terms. One topic could be a factual search, which is less dependent on index terms, as we know from previous research. Then users assess the relevance of each document found using a grayscale rather than binary, say from 0 to 4, from not relevant to highly relevant. And we also need to instruct users on how to assess relevance in order to increase inter-rater consistency. And then we finally compute retrieval performance metrics. And we could also conduct complementary research like log analysis, observation, questionnaires, and interviews. And we end with performing a detailed analysis of retrieval failures and successes, trying to judge why certain methods worked better than others. In conclusion, we saw that some claims that their thematic tools are highly successful, which is especially the case for a smaller number of topics and for commercial solutions. But we are faced with big evaluation challenges, and therefore we have proposed a framework comprising 3 aspects: direct evaluation in the indexing workflow, and indirect evaluation through retrieval, which also needs to be informed by empirical evidence. And some references will be provided in the end. Thank you very much for your attention.
Okay, thank you very much, Cora. Are there any questions? Okay. Okay, so if there are no questions, then I propose we move on to...
There was a question.
Yes. You suggest creating a proper gold standard using subject areas that have good coverage. However, it is also very interesting to evaluate performance on subject areas with fewer data. Is that possible too?
Yes, of course it is, especially if, we want to examine the effect of fewer training data on performance. What then will be the challenge is to invest more resources in creating a proper gold standard, because we will have fewer metadata already assigned and so forth. The only reason really for suggesting that is to be able to have more sturdy and trustworthy results based on more statistics. But certainly there are other cases when we want to test how good the algorithm performs with fewer data that are interesting in this context.
Okay. Thank you very much. So I'd like to introduce now the next 2 speakers. Annemieke Romein of KNAW Huygens Institute for Dutch History, and Sarah Veldhoen of the National Library of Netherlands.
Thank you. We are going to talk about a case study we did with Annif, and it's historical legislation that we looked at. We will be just briefly about us. I'm Annemieke, I'm a researcher, and I did a researcher in residence project at the Dutch National Library, which basically entails that I wanted to work with their collection, and they provide help with doing that with a research software engineer, and that was Sarah in this case, who helps out on the technical part of such a digital humanities project. And Sarah knows much more about the technical side, and I will be explaining a little bit more about the historical context in which my research question took place. So we briefly will talk about the hypothesis that I formulated, then we talk about our sources in numbers, how did we prepare our sources or our data, and then what kind of categories were we dealing with, and then how Sarah will be talking about how she trained Annif. What I want to know is how early modern legislation from one country to another influence each other. So how did the text influence, for instance, from Holland, the text from Flanders or from Utrecht? And that requires knowing what they all refer to. So metadata and topic modeling could be interesting ways of solving that, and seeing whether texts are similar from one place to another without having to read them all full text. So early modern legislation was promulgated and stuck to walls of known places such as markets or this paalhuis you see here in Amsterdam, so that people could actually read them. These texts have consequently been collected in books of ordinances, and these are a huge stack of books, and we have used them for the provincial legislation. And well, these collections basically have all the texts consequently put after one another. So there is not one text per page, but sometimes you have 6 texts per page, and sometimes you have one text for several pages. So that required some segmentation, but we'll talk about that in a little. We uncovered about 108 books for the Low Countries, and from that there were 88 in Roman font and 20 in Gothic, and we had to deal with several languages, but about 75,000 pages we needed to deal with, or at least that was the hope we had. Obviously, a project of 6 months is a bit ambitious to cover all those grounds, but what we did was we taught the computer how to read and how to segment the text. And contrary to the Google Books project, the texts weren't really readable when you're dealing with Gothic text. So we needed to train a model, and we did so with Transcribus. Transcribus is known as a handwriting text recognition tool, but print text can just be seen as a very regular handwriting. So we trained models to read these texts, and we also trained some segmentation, which in the end we did on a rule-based tool, just to speed things up within this project. But we segmented the text so that we knew where the title of the text was and where the end of the text was, so that Sarah could enjoy a little bit of fun with Annif in these texts. So we had well-readable text thanks to Transcribus, and now we wanted to figure out whether the computer was able to categorize these texts. So I had manually labeled about 3,000 texts. In this case study, we used 470 of those pre-labeled laws, and we applied a hierarchical categorization. So it was already a existing classification that we used from the Max Planck Institute for European Legislation. And they have a 4-layered categorization, and we added a 5th layer because we needed to determine whether something was an ordinance or not. There were some international treaties in these books as well. And we converted this hierarchical categorization into a SKOS, so a short knowledge organization system. And in the next image, you will be you see how this categorization basically looks like. The first question was, is it an ordinance or not? And then you had a division into the top categories, and this was then split out into more specific categories. And in total, we had about 1,800 categories that could be chosen from. And with that, I had already pre-labeled these legal texts, and now we wanted to know whether the computer could basically take over and automatically categorize according to this this set of potential categories.
Yes, so that's where I'll take over, as I did the Annif programming. At the KB's, the National Library of the Netherlands, we have been experimenting a bit with Annif already for our thesaurus of subject terms, the Brinkman thesaurus. And what I really liked about Annemiek's project is that this categorization is very strictly hierarchical. And I was interested in how Annif would deal with such a categorization system. So as Annemieke already explained, we had 470 labeled documents, where each document is single law, and those were pretty short text, so mostly 1 or 2 paragraphs or something like that. And she manually assigned subjects to them. At maximum 10 subjects, on average, they were 3.3. And those annotations were as specific as possible. So 70% of them were at the deepest level and 28 on the next deepest level. And we set up Annif to train per category level. So at level 5 to have those really detailed terms, but also at level 3 to have more the general terms and to see if we can broadly subject index the documents. Because we had very limited data, we did a tenfold cross-validation to get a bit more insight and a bit more stable results, of course. Unfortunately, it was really at the end of the project that we started to work with Annif, so we only tried the simplest backend TF-IDF, but Annemieke has plans to continue this research with more advanced Annif models. So that's really cool. And we used the Annif hyperparameter optimization to determine the hyperparameters of the limit. So 4 terms for each document were suggested, and the threshold. So Osma earlier showed that every possible subject gets a score, and we said the threshold only for subjects that have a score above 0.4 are actually reported. And at first we also determined the majority baseline, and that is on every level in the hierarchy, we just say if we pick the most frequent term at that level, what would you score in that case? So at the highest level, which is either police legislation or international law, the baseline is already very high because more than 95% of the document actually is about police legislation. And that makes it really hard to beat that baseline. So in this case, you see that the model performs worse than the baseline. But at the deeper levels of the hierarchy, the model starts to improve over the baseline. So what you see in the graph is the majority baseline is in purple, and the precision at 1 for both the test in red and in blue and the train set in red. So the precision at 1 means that you, for the highest ranked subject that is suggested, measure whether that's actually also assigned to the document manually. And while train precision, you can see that it's much higher than the test precision. And that's mostly due because the amount of data was very limited. So you have a lack of generalization of the model. And there's also a lot of variance, especially in the test precisions. That's the variance over those tenfold. So you can see that on average is the middle line, but there's a lot of variation in score between the different folds of the data. But of course, it is more interesting also to look at how well it does on several terms, because we know that several terms are assigned to every document. So we measured precision and recall at 4, predicting all those 4 terms. And then precision indicates whether the terms suggested by the model are actually also correct according to the manual annotation. Whereas recall measures to what extent the manually assigned terms were actually also suggested by the model. And we display here the micro-averaged results, because there's different ways you can create an average from all the suggestions. We chose the micro-averaged data because it's more robust against imbalanced data. If you have one class that's very frequent, another class that's very infrequent, both of them have the same, examples from both of them have the same impact. And you have to know that at level 4 and 5, so at level 4, 163, and at level 5, 1,584 categories were available. And you see that the model is able, so that's at level 5, the rightmost column, the recall is already 40%. Thus 40% of the manually assigned terms were also suggested by the model. And I think given the limited amount of data, that it's a pretty impressive result. However, the precision is still quite low. So there's room for improvement. But we believe that adding more data, as Annemieke is working on right now, will increase the performance. And it would be really interesting also to look at the different models to see how well they do, especially Omikuji, as it's a backend that's also very good at imbalanced data. I think that could be very useful for this kind of data as well. So yeah, that was something that we really ran into, that the amount of data was very limited. And there's also some things about specifically this data. So many other scenarios in which you use Annif, for instance, what Osma showed with the BBC News, you have proper text and it's modern text. But because we digitalized those texts and had transcribers transcribe all the text in them, there are always some errors that occur. And that makes it harder for a model to recognize words. If there's one letter that is misspelled, it already doesn't know what word it is. So that has an impact, and it will be interesting to measure that impact too. And for now, we use the Snowball Dutch stammer, which is integrated into Annif. It's from an NLTK package. But it would also be really interesting to see if the historical language has an impact on the performance, because in historical Dutch, there's no strict spelling guideline. So there's a lot of variation. Even within a text, the same word could be spelled in different ways, which makes it hard for a model to recognize that it's actually the same word, so that it means the same thing. And also, I think for this project, but also for Annif in general, it would be really interesting to see how the hierarchy in the categories can be used to improve the results. I think many thesaurus have some kind of hierarchical system, and it could be really useful to have a model that is, or a backend that's really aware of that hierarchy. So I put a few pointers in here. The first is the publication about this project at the Benelux Journal. We have some information on the KB lab website, also some blogs and the data set of this project, if you're interested in them. And at the bottom, I put a bullet with some other work we do at the KB with Annif. And we also continue to work with Annif in different settings for subject indexing documents and to seeing how we can aid our cataloging department also using Annif. And as I said, Annemieke continues to work on the early modern legislation in her project at the Huygens Institute. It's called Game of Thrones. And I hope she'll be able to do some more experiments with Annif on bigger data. She always also plans to include data from different countries, because there's also, I think, a lot of data from Germany and Switzerland that has already been annotated with the same categories. So it would be really interesting to see how that performs, and maybe also look at the multilingual setting, how to deal with that. And as I said, in the KB, we're still continuing to experiment with Annif in a tool. And I gave a talk on that pretty recently. So if you're interested, you can also check it out. That was it. So I'm curious to hear if there's any questions.
Okay, thank you very much, Annemieke and Sarah. We have a question. Okay, at the start, Annemieke, at the start you mentioned a research question. To what degree does automated subject indexing help with that in relation to topic modeling? Osma, could Annif also do topic modeling?
Well, for me, it's important to stick to the categorization that has already been created in Germany, because I would like to, in the longer run, connect all the legislation from the Low Countries to the German legislation through linked data. And if I were to use topic modeling, then the computer would have a go and would spit out various topics, and the different, well, it would probably use different words than when I do topic modeling on German sources, besides from just the language. So if I have a restricted subject categorization pool of words that it could use, then chances are that I would end up with words that are well, nearly similar, or at least similar to apply. And with that, I hope to be able to make this connection through various territories more easily. And as we have shown, well, we do need more training data, but Annif performs really well. And if we can then make the next step to link data, it will be possible to see if my laws actually traveled, or at least the topic. So if you have wandering soldiers moving from one area to another, it would be more easy to track whether they created legislation on these troubles that the soldiers created just by looking at the topic of soldiers or plundering or whatever. But because we restrict the topics that the computer could choose from, it's easier to do this kind of research rather than topic modeling.
And to the question of whether Annif can do topic modeling, so at the moment, no, and I'm basically echoing what Annemika just said, but we started from a library context where the controlled vocabularies are very important, especially for semantic interoperability. So you have many collections using the same vocabulary, which makes it possible to combine them and do a combined search and so on. So topic modeling hasn't really been relevant for us. Yeah.
Maybe I should stress that legal texts have a very defined vocabulary, so that there's little room for interpretation either. So that's something that's very beneficial when trying these kind of tools out on legal text.
We have another question. Just about a clarification of terminology. The presentation referred at some time to classes. What does class mean in this context, and what is the role of classes in subject indexing?
I think when we write class, we mean the subject label. So in machine learning, this problem is named classification, because you have to apply a class to every document or several classes. So you can just view class as a subject.
Okay. So if there are no further questions, then if you all agree, I think we can move on to Osmos. Yeah?
Yeah, that's what I thought. See, can you see my screen? My
yes.
slide. Okay. So I'll give a few examples of where Annif is already used in production. And so first of all, the first, let's say the early adopter of Annif was the University of Jyväskylä, and they have a repository called Yux for storing, among other things, the thesis of their students. And so for their students, once they complete their thesis, they place it here in the repository, and the students themselves are doing it. So they are basically uploading the thesis and filling in a form with the metadata about the thesis. And before they started using Annif, the students were basically given in the metadata form, they had an empty field for subject. Just like type in the keywords or the subjects of your thesis here. And it was like the problem here was that basically everybody was doing this for the first time, and most of the students were not familiar with the subject indexing and with the vocabulary they were using. So they had a lot of problems with this. And so they started using Annif instead. And here the idea is that when the students upload their thesis, the text of the thesis is given to Annif, and then Annif suggests some possible topics or subjects for the text. And then the students get a list like this, where they can then choose the what they think are the most appropriate topics. And for them, this was a relief, because it's a much easier task for the students to just select the appropriate topics from the suggestions instead of coming up, you know, from scratch. They can, of course, also assign subjects that were not suggested by the algorithm. And but then there's also a librarian in the loop who checks the subjects and the other metadata given by the students before it's published. So there's also a professional librarian part of the process. And a very similar process was implemented recently by the University of Vaasa and their repository called Osuva. And it's just technically a different implementation, but it's the same idea. We started doing this in the spring. Then another case of using Annif in production is a company called Kirjavälitys. It's a very it has a very central role in the, let's say, the book ecosystem in Finland, because it's a company that handles the logistics between publishers and booksellers. And it also handles the metadata part of that logistics. So it collects information about new books being published, and then passes this information on to everyone who needs it. And what they have started doing is that when they get information about new titles from publishers, they send, they give the text, the description of the book to Annif, in practice the Finto AI service, which I will talk about briefly in a moment. They give this to Annif, and then Annif provides suggestions for subjects, and then there's a person in the company who performs correction and curation again, and then finally the metadata is distributed to bookshops and online stores, and also to libraries. For example, the Melinda Union Catalog, which is a large, the main catalog of main bibliographic catalog in Finland, and includes also the Fennica National Bibliography, and also directly to some public libraries. So in this case, they have been able to provide more detailed, more specific metadata about upcoming titles than before. So previously, the cataloging was only done when the when the book was actually published, but now they have started doing the initial subject cataloging earlier, when they only have the preliminary information about the book. Then at the National Library, we recently, in May, we launched the Finto AI service. It's like a sister service to Finto, the thesaurus and ontology service. And this is basically a service built around Annif. And it has the same basic user interface, just slightly different layout or design. But so it works either as a web form or as an API service in 3 languages: Finnish, Swedish, and English. So you can give it text, and it will suggest subjects. And with this, we after developing Annif for about 3 years, we made it into a production system. So we are, of course, continuing the development of Annif as a general purpose tool, but this is a sort of more specific service to, especially to Finnish libraries that we provide. And then I will talk a little bit about evaluation, and Cora gave an excellent introduction into how this should be done. and many ideas. I'm afraid we don't quite live up to those ideas, because in many cases the evaluation is just part of the many development tasks we are doing, and we cannot invest all our resources only in that, but we are still doing quite a bit of it. And first of all, I'm reflecting on the approaches that Cora presented, and there were three kinds of approaches, and the first was to evaluate directly through assessment by an evaluator or by comparison with a gold standard, and the second one was to evaluate in the context of an indexing workflow, and then the third one was retrieval performance. Well, we've done some of the first and the second, not so much of the third one. And so first of all, assessment by evaluators. So here, I guess the main thing we've done is that we organized a workshop about, end of last year. And as you can see in the picture, we had about 50 people in the room, and they were given 50 example documents as printouts mostly, or in some cases physical books. And then they were given candidate subjects for those documents. And these candidate subjects were collected either from human indexers who had been assigned these subjects, or for different algorithms. And after doing this exercise, which took about 2 hours, we were able so the tasks given to these evaluators was to rate the suggested subjects and to mark the ones that were inappropriate. And they were rated them on 3 different measures, on coverage, and then the specificity, and then general quality. And I'm sorry, the diagrams are in Finnish, but I'll try to explain here. So here the red bar is the best performing ensemble algorithm, and the bluish bars are all variations of human indexing, slightly different from slightly different sources. And in all 3 quality measures, the algorithm was clearly weaker than the human assigned subjects, but the difference wasn't dramatic. I mean, there is a difference clearly, but it's almost competitive, I would say. And then in terms of the inappropriate subjects, but less than 10% of the subjects assigned by humans were rated as inappropriate, whereas it was more than 20% for the best performing algorithm. So clearly the algorithm often suggests inappropriate subjects more often than humans. And there's also an article, unfortunately, that's also in Finnish. You can try Google Translate on it, but we wrote an article about this workshop. And a similar exercise was conducted recently at the Finnish broadcasting company Yle, and they wanted to compare the quality of Annif versus or against the Leiki platform, which is a commercial service they are currently using for the subject indexing of their news articles. So they chose 100 articles in Finnish and 100 in Swedish from 4 different subject areas, and the subjects that had been assigned to those. And they the evaluators were given this kind of form where they had to rate the subjects without knowing where the subjects came from, whether it was from Annif or Leiki, and that they had to say whether it's essential, okay, non-relevant, or wrong for each of these subjects. And in the results for Finnish, Annif was given slightly higher scores than Leiki. So there were more of the essential and okay ratings and less of the non-relevant and wrong. But the difference was not very big. But for Swedish, interestingly, the result was actually very different, and the Annif was performed much better than Leikki in all the subject areas, and especially in business and science, the difference was very large. There have been some speculations about the reasons for this, but one possible explanation is that traditionally the Swedish language department of YLE has put a lot more effort into their subject indexing, and since this the models, Annif models, were trained on the old indexed articles, it's possible that the algorithm benefited from the better quality training data in case of Swedish, whereas in Finnish they have been using the Leikki algorithm for a long time, and it's possible that a lot of the metadata is just coming almost directly from the Leikki algorithm, so Annif might just end up imitating Leikki instead of basing it on good quality metadata. Okay, so that was the evaluation of subjects. Then we've also done some comparisons about against the gold standard, and here it's good to know the measures that are commonly used, especially precision recall and the combination F1 score. Well, Sarah already talked about precision and recall, so I won't repeat that. And the F1 score is just a way to combine the precision and recall into a single measure, which is the harmonic mean of the precision and recall. And so here I'm showing some comparisons against various gold standards, but I put gold standard in quotes here because could argue that it's not a very high quality gold standard. In most cases, we have just relied on the existing metadata from the catalogs, and sometimes it's better, like for example in the case of the Finnish national bibliography, where the subject indexing is quite high quality, but in other cases it can be low quality metadata. In any way, here the bars are showing the F1 scores of the similarity between what Annif suggests and the gold standard for various data sets. Here are 6 different data sets in Finnish, and 3 in Swedish, and 3 in English. And each color of a bar is one particular version or setup of Annif, and so the gray one is the first prototype, and then the blue one is the next one, and so on, and the most recent one is the purple one. And you should see here the pattern that in almost all cases we have been able to significantly improve the quality of the algorithm suggestions over time. So the most recent model is much better than the previous versions we've had. And except for the first one, all of these newer models are basically ensembles consisting of several algorithms working together. So this has been an important way for us to improve the quality, to train many models and combine them into ensembles. Then also briefly about evaluating in the context of an indexing workflow. So what we have been able to do is to collaborate with the University of Jyväskylä, who have been using Annif in the YIX repository, as I told you. And so they provided us with some data about how often the students selected the subjects suggested by Annif. And the data covers 2 different periods. The first period is the original prototype of Annif, and then the second period is a newer version in 2018. And the bars here show the similarity of the suggestion by Annif and the selections either by the students, which is the blue bar, or the final subjects which were verified by a librarian. So what's apparent here is that the prototype did not perform so well, so only a third of the suggestions were accepted by the students. But the new version, the next year, which is already 2 years ago and an old model by now, about half of the suggestions were acceptable. So, so clearly there has been an improvement, and we haven't collected the similar data for later times, but it would be possible to do a comparison also to the more recent models. And some of the lessons from the evaluations we have done. So echoing what Cora said, I think the different evaluation approaches are complementary. So it's not a good idea to look at just a single measure, for example, similarity between against the gold standard, because that might be misleading. So it's good to use multiple approaches in parallel when it's feasible. But of course, many of these evaluations are quite labor intensive. You need, for example, a room full of people for 2 hours or something similar virtually, like Yle did. And so you can't, I mean, you can't spend all your time on this. And clearly the quality of automated subject indexing we're doing has improved over time. And part of it is that we have, over time, we've got access to better training and evaluation data, but also, of course, better algorithms. And especially Omikuji has been very good for us. And another improvement was the neural network ensemble, which is a more advanced ensemble method that can sort of better identify when a particular algorithm is trustworthy and when it isn't. But it's evaluation, it's a continuous process. It will never stop, and we will keep doing it just to make sure we are making progress. Then I want to say something about a hands-on tutorial we have prepared, which is a sort of a continuation of today's session. So if you are interested in learning to use Annif for yourself on your own data, then I warmly recommend that you take a look at this. So this is a tutorial we prepared together with the Leibniz Information Center for Economics, ZBW, which is a German library for economics literature. And so we put together materials that are freely available for anyone who's interested. And so you could say that the tutorial consists of 3 parts. The first part is understanding what Annif is. And since you're listening to this presentation, this basically covers this part. So you should already have a general understanding what Annif is. And the second part is the hands-on tutorial, which consists of videos and exercises, written exercises. And this is something that is designed to be done on your own time, on your own schedule. And you should be able to follow the instructions to install Annif and to complete the exercises. And there are also some example data sets, so you don't have to have your own data available yet to be able to do this. And finally, if you want to get some, or if you need more support or want to discuss what you've learned, we arrange also some online sessions where you can ask questions, get help, discuss what you've learned, and so on. And I will tell more shortly. There's currently a set of 14 videos which are available on YouTube, and you're not expected to watch all of them. Some of them are, you can take different paths through this material depending, for example, on what kind of installation you have of Annif. So, but yeah, so there's plenty of these available. They are all less than 10 minutes each, so short videos. And then there are these exercises, and these are divided into core and optional exercises. The blue ones here are the core ones. So you should complete at least the core ones to get a sort of a good general understanding of what Annif can do. And then the optional ones are if you want to learn more about a particular topic. All of the material is in the Annif tutorial repository on GitHub, and you can go there to find it. And then about the online sessions, we have scheduled 2 sessions for October. The first one is on Friday, the 9th October, the same time as this session was, so early morning European time. And then another one is on the Wednesday, 21st of October, which is later in the day and in the afternoon in Europe, late afternoon, early evening. And in both cases, the registration starts 2 weeks before. But if you want to register, you should already have watched the videos and tried to complete the exercises, or at least are planning to do so before the session, because the idea is that you try to get as far as you can with the materials we have, and then if you get stuck, we can help you during these sessions. And there's more information, and the registration links will be put also in the Annif tutorial GitHub repository. Finally, I wanted to mention that we have started an interest group on automated subject indexing at DCMI, and the group has a web page, which is here, and a mailing list that you can subscribe to. And we've also scheduled an online meetup for the 6th of November in the morning European time. And if you want to, you can join the session, and we want to keep it as an informal meetup where everybody has maybe 5 minutes to introduce themselves and tell what their relation is to automated subject indexing, what they would like to do, and this is a chance to network, to meet people, and to get help with your projects on automated subject indexing. And this is more general than just Annif, so any discussion relevant to automated subject indexing, for example, on evaluation practices or commercial tools or services, is also relevant here. But that's it. Thank you from my side. And here's also a picture of my team. Juho and Mona are also working on Annif and the tutorial materials together with me at the National Library. And at the bottom, there's the link to the slides as well, if you want to check out something.
Yeah, thank you very much, Osma. We could end it here because we're almost at the end of our time slot, or we could potentially take 1 or 2 questions if there's interest. There's one question. Annif uses 5 or 6 algorithms such as MAUI or TF-IDF. Are many algorithms such as these being developed, perhaps as based on different approaches, and to what extent are they available as open source as opposed to closed source or commercially licensed?
Okay, so maybe I can answer this. Yes, we have some new algorithms in the pipeline, and for example, recently there was a pull request from the ZBW, the German Economics Library, who have implemented their own lexical algorithm, which is especially meant for short text, such as when you have just a document title or a short abstract. And so this is in the process of being integrated to Annif. Also, we have a collaboration with the CSC, which is Center for IT. They are basically helping Finnish universities with running supercomputers and stuff like this. And they are testing algorithms for us, potential new candidates to be integrated. And they were the ones who found Omikuji as well. And right now they are testing some algorithms based on neural networks, heavy algorithms, for example, using the BERT model, language models. And it's possible that eventually this will also lead to new algorithms being integrated with Annif. All the ones that I'm aware of are open source. So I haven't seen any commercial systems in this. I mean, there are commercial systems, but they are, as far as I know, not being integrated with Annif.
Okay, we have another question. Osma, have you explored the quality of Finto vocabularies for lexical indexing? For example, good hierarchies for disambiguation, plenty of synonyms and the such. Would vocabulary owners be interested in improving them this way? I think this would also improve information retrieval.
Yes, that's right. We haven't done any formal evaluation, but this is one of the sort of this is on the back of our minds when these vocabularies are being maintained and developed. So, for example, we try to add synonyms, of course, also to the benefit of human indexers, but also algorithms. I think this is getting more relevant now that we are sort of rolling out the services for automated indexing, especially Finto AI. So yeah, I think that there should be an interest in this area, but it's just, it's just starting.
Okay, so if there are no further questions, I want to thank Osma, Cora, Anamika, and Sara for the great presentations, and thank you all for attending this this session. The recording will be available for the duration of the conference, and it will be made available. Osma, do you want to comment on that? The recording will be made available pretty soon after the end of the conference.
Yes, we are trying to make it available by the end of this week, at least on the National Library of Finland YouTube channel. But I think DCMI will also publish it on their YouTube channel.